Hello students, I am Subhashish. Having familiarized ourselves with the concept of real numbers, representing them on the number line and manipulating them, learn about surds, a distinctive way of representing certain approximate values. Children, can you simplify root 4 and remove the symbol root? Yes, one can replace root 4 by the number 2. How about root 1 by 9? It is easy. Without root a symbol, the answer is 1 by 3. What about root 0.01? This is also easy and the solution is 0.1. In the cases of root 4, root over 1 by 9 and root 0.01, you can resolve to get a solution and make sure that the symbol root is not seen in your solution. Is this possible at all times? Consider root 18. Can you evaluate it and also remove the radical symbol? Surds are unresolved radicals such as square root of 2 and cube root of 5, etc. They are irrational roots of equations with rational coefficients. In this class, let us study surds. Learning outcomes. To identify surds, to carry out basic operations of addition, subtraction, multiplication and division using surds. Keywords from this lesson are numbers, rational numbers, irrational numbers, pure and mixed surds, simple surd, compound surd, binomial surd, loss of radical, addition, subtraction, multiplication, division. A surd is an irrational root of a rational number. Nth root A is a surd provided n belongs to natural number, n greater than 1 and A is rational. Example, x square minus 2. Root 2 is a surd. It is an irrational root of the equation x square is equal to 2. Note that x square minus 2 is equal to 0 is an equation with rational coefficients. Root 2 is irrational and may be shown as 1.41421 and so on, a non-reoccurring, a non-terminating decimal. Cube root 3 is a surd since it is an irrational root of the equation x cube minus 3 is equal to 0. Root 3 is irrational and may be shown as 1.7320508 so on, a non-reoccurring, non-terminating decimal. Is root over 1 by 25 is a surd? No, it can be simplified and written it as rational number 1 by 5. How about fourth root 16 by 81? It is not a surd because it can be simplified as 2 by 3. The famous irrational number pi is not a surd. Though it is irrational, it cannot be expressed as a rational number under the root symbol. In other words, it is not the root of any equation with rational coefficients. Why surds are important? For calculation purpose, we assume approximate values as root 2 is equal to 1.414, root 3 is equal to 1.732 and so on. root 2 whole square is equal to 1.414 whole square, which is equal to 1.99936, which is not equal to 2. Root 3 whole square is equal to 1.732 whole square, which is equal to 2.999824, which is not equal to 3. Hence, we observe that root 2 and root 3 represent more accurate and precise values than their assumed values. Engineers and scientists need more accurate values while constructing bridges and for architectural works. Thus, it becomes essential to learn surds. Order of a surd. The order of a surd is the index of the root to be extracted. The order of the surd nth root A is n. What is the order of fifth root 99? It is 5. Surds can be classified in different ways. Surds of the same order. Surds of the same order are surds for which the index of the root to be extracted is the same. They are also called equiradical surds. For example, root x, a power 3 by 2 and square root m are called second order surds. Cube root 5, cube root x minus 2, ab power 1 by 3 are all third order cubic surds. Root 3, cube root 10, fourth root 6 and 8 power 2 by 5 are surds of different order. Simplest form of a surd. A surd is said to be in simplest form when it is expressed as a product of a rational factor and an irrational factor. In this form, the surd has the smallest possible index of the radical sign, no fraction under the radical sign. No factor is of the form a power n, where a is a positive integer under index n. Let us see one example. Can you reduce the following numbers to surds of the same order? Fourth root 3 and cube root 3. Solution. Fourth root 3 is equal to 3 power 1 by 4. Multiply and divide with 3 to power 1 by 4. We get 3 power 3 by 12. According to the formula, it can be written as 12 root 3 cube, which is equal to 12 root 27. Cube root 3 is equal to 3 power 1 by 3. Multiply and divide with 4 to power 1 by 3. Then we get 3 power 4 by 12. According to the formula, it can be written as 12th root 3 power 4, which is equal to 12th root 81. The last row has surds of the same order. Pure and mixed surds. A surd is called a pure surd if its coefficients in its simplest form is 1. For example, root 3, cube root 6, 4th root 7, 5th root 49 are pure surds. A surd is called a mixed surd if its coefficients in its simplest form is other than 1. For example, 5 root 3, 2 into 4th root 5, 3 into 4th root 6 are mixed surds. Simple and compound surds. A surd with a single term is said to be a simple surd. For example, root 3, 2 root 5 are simple surds. The algebraic sum of two or more surds is called a compound surd. For example, root 5 plus 3 root 2, root 3 minus 2 root 7, root 5 minus 7 root 2 plus 6 root 3 are compound surds. Binomial surd. A binomial surd is an algebraic sum or difference of two terms, both of which could be surds, or one could be a rational number and another a surd. For example, 1 by 2 minus root 19, 5 plus 3 root 2, root 3 minus 2 root 7 are binomial surds. Let us see one example. Arrange in ascending order cube root 2, square root 4, 4th root 3. Solution. The order of the surds cube root 2, square root 4 and 4th root 3 are 3, 2 and 4. LCM of 3, 2 and 4 is equal to 12. Cube root 2 can be written it as 2 power 1 by 3. As we got LCM 12, we are multiplying it by 4. Then we will get 2 power 4 by 12. So according to formula, writing it as 12th root 2 power 4. Square root 4 can be written as 4 power 1 by 2. Multiplying by 6, we get 4 power 6 by 12. According to the formula, we can write it as 12th root 4 power 6. 12th root 4096. 4th root 3 can be written as 3 power 1 by 4. By multiplying by 3, we get it as 3 power 3 by 12. According to the formula, it can be written as 12th root 3 power 3, which is equal to 12th root 27. The ascending order of the surds cube root 2, 4th root 3, square root 4 is 12th root 16 less than 12th root 27 less than 12th root 4096. That is cube root 2, 4th root 3, square root 4. Loss of radicals. For positive integers m, n and positive rational numbers a and b, it is worth remembering the following properties of radicals. We shall now discuss certain problems which require the loss of radicals for simplifying. Let us see one example. Express each of the following surds in its simplest form. Cube root 108. Find its order, radicand and coefficient. Solution. Cube root 108 can be written as cube root 27 into 4. 27 can be written as 3 cube, which is equal to cube root 3 cube into 4. By separating the terms, we get cube root 3 cube and cube root 4 by law of radicals 2. By cancelling, we get 3 into cube root 4 by laws of radicals 1. Now therefore, order equal to 3, radicand equal to 4 and coefficient is equal to 3. These results can also be obtained using index notation. 4 basic operations on surds. Addition and subtraction of surds. Like surds can be added and subtracted using the following rules. A nth root b plus or minus c nth root b is equal to a plus or minus c nth root b where b greater than 0. Example, add 3 root 7 and 5 root 7, check whether the sum is rational or irrational. Solution, 3 root 7 plus 5 root 7 is equal to 3 plus 5 into root 7. By taking common, we can write it as 3 plus 5 into root 7, which is equal to 8 root 7. So, it is irrational. Subtract 4 root 5 from 7 root 5. Is the answer rational or irrational? Solution, 7 root 5 minus 4 root 5 is equal to, by taking common, we can write it as 7 minus 4 into root 5. After solving, we get which is equal to 3 root 5. So, it is irrational. Let us see one more example. Simplify the following: root 63 minus root 175 plus root 28. Solution, root 63 minus root 175 plus root 28 is equal to, 63 can be written as root into 9 into 7 minus 175 can be written it as root over 25 into 7 and root 28 can be written it as root over 4 into 7. Root 9 is 3, which is root 7, root 25 is 5, which is minus 5 root 7, root 4 is plus 2 root 7. By adding 3 root 7 plus 2 root 7, we get 5 root 7. Now, by adding 3 root 7 and 2 root 7, we get 5 root 7 minus 5 root 7, which is equal to 0. Multiplication and division of surds. Like surds can be multiplied or divided by using the following rules. Let us see one example. Compute and answer the simplest form: 2 root 72 into 5 root 32 into 3 root 50. Solution, 2 root 72 into 5 root 32 into 3 root 50. Root 72 can be written it as root over 36 into 2. Root 32 can be written it as root over 16 into 2. Root 50 can be written it as root over 25 into 2. Root 36 is 6. So, root 72 can be written it as 6 into root 2. Root 16 is 4, can be written it as 4 into root 2. Root 25 can be written it as 5. So, it is written as 3 into 5 root 2. Rearranging all the number terms and root terms, we get by multiplying all the terms, we get 3600 into 2 root 2. root 2 into root 2 is 2. 3600 multiplied by 2 root 2 is equal to 7200 into root 2. Let us see another example for division. Divide 9th root a by 6th root 6. Solution. 9th root a by 6th root 6 can be written it as by using formula 8 power 1 by 9 by 6 power 1 by 6. By multiplying 2 to the numerator and 3 to the denominator, we get 8 power 2 by 18 by 6 power 3 by 18. By taking 1 by 18 common, we can write as 8 square by 6 cube into whole power 1 by 18. Now by expanding, we get 8 into 8 by 6 into 6 into 6 whole power 1 by 18. By cancellation, we get 8 by 27 into whole power 1 by 18. Eight can be written it as 2 cube and 27 can be written it as 3 cube. So we get 2 by 3 whole cube into whole power 1 by 18. By cancelling, we get 2 by 3 into 2 by 3 whole power 1 by 6. By using formula, we can write it as 6th root 2 by 3. Points to remember. If a is a positive rational number, n is a positive integer, if nth root a is an irrational number, then nth root a is called a surd. If m, n are positive integers and a, b are positive rational numbers, then nth root a whole power n is equal to a is equal to nth root a power n. Nth root a into nth root b is equal to nth root a into b. Nth root of a is equal to mn root a is equal to nth root of a. Nth root a by nth root b is equal to nth root a by b. Thanks for watching.